in this topic, we will discuss about the photodetectors. Photodetectors. So in case of LED, so what we discussed, that light energy is converted into electrical energy. In case of LEDs, so light energy is converted into, electrical energy is converted into light energy. In case of LEDs, so what happened, if you supply the some voltage, so voltage, that means that diode is connected in forward bias. What happened, electrons will move towards to the junction. Similarly, holes will move towards to the junction. At the junction, what happened, emission process will be occur. At the junction, electron will recombine with the hole. Electron will recombine with the hole. So in this process, light will be emitted. Light will be emitted. Okay, so this is electrical energy into light energy conversion. Electrical energy into light energy conversion. So that is working principle of LED there. Okay, so light energy is converted, electrical energy is converted into light energy in case of LED. Now photodetectors. In case of photodetectors, here, so opposite case. So previously light is emitted, but here light is absorbed. Light is absorbed. Okay, so when light is absorbed, what happened, it will be converted into electrical energy. In case of photodetector, so light is absorbed, so that due to that absorption of light, so what happened, electrical current will flow through this circuit. Why it will flow through this circuit, I will explain you. Okay, so in this case, what happened, so photo energy is converted into electrical energy. Electrical energy. Okay, so based on this principle, photodetectors will works. Okay, so now, so just go to the photodetectors. See here, so that photodetectors, here two types of photodetectors is there. So that means uh, first one is the light conductive element. Okay, directly if you will take the cadmium sulfate and here cadmium and scandium, combination of cadmium and scandium and lead sulfate. Okay, these three, so directly, so if you will take these elements, so these elements can pass the light, it's through it, can pass the light through it. Okay, so these elements we will call it as light conductive element. We will not discuss about this part here. Okay, so this topic also we are not discussing in this, so because these are the not semiconductors, so that's why we are going to the next one, photoelectromotive element. Photoelectromotive element. So in this also, so there are three types will be there in that photoelectromotive elements. So one is the PN junction diode. Its works, some works will be based on the PN junction diode. Another one is the NPN junction diode. NPN transistor will be there. Na? So here this is only PN junction. So this is NPN. So N junction, P junction, and N junction again. Okay, this is the NPN junction. So simply we will call it as these are the transistors. Okay, so transistor topic also not there in our syllabus, so that's why we are also not discussing this. And next one is the photo ICs, so photo chips. Okay, integrated chips will be there, so will not discuss about this also. Okay, so mainly we are discussing about here PN junction diode. PN junction diode. So based on PN junction diode, by using PN junction diode, how photo detectors will made. Okay, so first one is photodiode. By using PN junction diode, we can prepare a photodiode and PIN diode. PIN diode and so APD avalanche photodiode. APD avalanche photodiode. So these three mainly we will discuss here. These three mainly we will discuss. So if you will observe the NPN junction diode, in that also phototransistor will be there. Darlington phototransistor will be there. So we are also not discussing this. Okay, so only, so based on the whichever works, so based on the PN junction diode, so those we are discussing here in this topic. Okay, so that is, so these three, photodiode, PIN diode, and APD, avalanche photodiode. Okay, so mainly we are focusing on these three parameters here. Okay, now, so we are going to the photodetectors. What is the photodetector? What is the photodetector? So already, so I give just little introduction about that. See here once again. semiconductor device which can implicated to detect the photons presence. Such device are known as photodetector. Okay, so let us take any semiconductor device. So generally we'll use it as a PN junction diodes. PN junction semiconductor diodes we will use. Okay, so if you keep that PN junction diode in the presence of some photons, that means some presence of some light. Okay, so presence of photons, what happened? Some electrical current flow through the circuit. That means, so those semiconductor detects that photon, detects that photon, and it shows some readings. It shows some readings. Okay, depends on the our settings how it will be setted. How it will works means, so whenever light will be instant on the PN junction diode, light will be instant on the PN junction diode. What happened? So in that PN junction diode, there are two regions will be there. One is the P region, sorry, another one is the N region. N region. Okay. When light is instant on the PN junction diode, so that valency in case of N region, that valency band electron will goes to the conduction band. Valency band. So that in that valency band, so many covalent bonds will be there. So that covalent bond will, whenever it absorbs the photon, whenever it absorbs the photon, that covalent bond will breaks. Covalent bond will breaks, and electron hole pair will generate. Electron hole pair will generate. Okay, if electron hole pair is generating means, so electron will goes to the conduction band, so hole will be in presence in valency band. So that's why what happened? Charge carriers will be increases. So charge carriers will be increases means there is a more charge carriers will be there means there is a chance of increasing of current. There is a chance of increasing of current in the circuit. So based on this phenomena, so this photodiode will works. Okay, photodiode will works. Yeah. So now the photodiode transform optical signal into electrical signal. So I just said that. So principle is here: optical energy is converted into electrical energy. Optical energy is converted into electrical energy. Okay. Now, so the next point: when excess electrons and holes are generated in a semiconductor, they produce electric current. Okay, whenever light is fall on a semiconducting device, whenever light is fall on a semiconducting device, what happen here? Excess electrons and holes will be generated. So why it will be generated means covalent bonds will be breaks when light is absorbed by the semiconducting material. What happen? So by using that light energy, so covalent bond will breaks. Covalent bond will breaks, and so electron hole pairs will be generated. So one thing we have to remember here, so that light energy should be greater than the energy gap between the valence band and conduction band. That light energies, so then only photodiode will detect. So that light energy should be greater than the uh, what is that valency band, energy gap between the valency band and conduction band. Then only so it will detect. So why it will means, so whenever light is, so suppose light is instant on, that means that's how less energy. Less energy means that energy is absorbed, but so what happened? Covalent bond does not breaks. So that electron will not move to the valency band to conduction band. Valency band to conduction band. So that's why. So because that energy is less, that's why what happened? There is no flow of current in the external circuit. So that's why photodetector does not work. So that's why. So this photodetector material should be very sensitive. Very sensitive. So that means that band gap should be very small. That band gap should be very small, then only it will detect the so very sensitive light also. Then only it will detect the very sensitive light also. Okay, understood? Okay, so that means that the band gap is very small. So if you want to use the so PN junction diode as a photodiode means, so the band gap should be very small. Then only it will works very accurately. Then only it will works very accurately, because so the band gap should be minimum. Then only it will absorb the very sensitive light also, very sensitive light also, and it will produce the current through the circuit. Okay. and now next one, response is proportional to the power of light beam. Okay, so how much power of light beam will be presence? So how power is nothing but here. So how many number of photons will be instant? How many number of, so that means intensity of the photons as well as energy of the photon. So that power will be depends on the intensity as well as energy of the photon. Okay, so that's why this response of photodiode is proportional to the power in the light beam. If power is light beam power is more means here, so current will be more. Current will be more. Okay, we'll discuss about that also, how it will be more. Okay, now principle of photo detection. Okay, photo detect photoelectric principle is based on the two types of photoelectric effects. Okay, photoelectric principle is based on two types of photoelectric effects. So here, what are the two types means? So external photoelectric effect and internal photoelectric effect. Okay, so we'll discuss briefly these two in this topic. So one is the external photoelectric effect and second one is the internal photoelectric effect. So what is the external photoelectric effect? Electrons become free from the metal surface by energy absorption obtained by stream of incident photons. See here, electrons will become free from the metal surface, by energy absorption obtained by the stream of incident photons. So if you observe this definition, so what is the definition means? If any photon will be instant on the metal surface, so what happened? So that electron will free from that metal surface. Okay, so that means electron will escape from the metal surface. Electron will free from metal surface means it will come out, electron will come out to the, so total material, so this effect we will call it as external photoelectric effect. Whenever light is instant on a so metal surface, what happened? So that light energy is absorbed by the electrons, and those electrons will come out from the metal surface, so previously what we discussed means electron will goes to the, so valency band to conduction band, I said that. So but here total electron is come out from the metal surface. If electron is come out from the metal surface means, so that will be a free electron. It will move, so in the space, not in material. This effect we will call it as external photoelectric effect. Okay, see here in which situations we will observe means, so for observing the external photoelectric effect, here we should have photomultiplier tube. So if electron will be released and it came out means, so if you should have either any tube. Okay, that means so then only that electrons will be present inside the tube, otherwise it will be yeah, so it will be move into the space. If it will be move into the space means we cannot detect it. Okay, that's why, so we will use here in external photoelectric effect, so photo multiplier tube. We will use the photo multiplier tube and vacuum photodiode will use here. Yeah, see here, so photo multiplier tube and vacuum photodiode are the implications of external photoelectric effects. Okay, so then only in the presence of photo multiplier tube and vacuum photodiode, so we'll observe this external electric field. So if you will not use this photo multiplier tube and vacuum photodiode means what happen? So that electrons will move to the normal. So suppose in our environment, if it will comes to the in our environment means we cannot detect that electron. That's why we should use this photo multiplier tube and vacuum photodiode for conducting the external photoelectric effect. Okay, so now next one is internal photoelectric effect. In this, free charge carriers are generated. Free charge carriers are generated by absorption of incident photons in semiconductor junction detectors. Okay, see here. Free charge carriers are generated by absorption of incident photon in semiconductor junction devices. Just now we discussed previously. Okay, so previously what we discussed, so how photodetector will works means, so whenever light is absorbed by the semiconducting material, light is absorbed by the semiconducting material, what happen here, so that electron will jump from valency band to conduction band. So here electron is, so what is that, bond is breaking, but electron just moving from valency band to conduction band. It is not coming out from the surface, it is not coming out from the material. Okay, it will be inside the material. Inside the material, that electron will move freely. Inside the material, that electron will move freely. Okay, so that means free charge carriers will be developed here. Free charge carriers will be developed. Those free charge carriers will be moved inside the material. Inside the material. So this photoelectric effect we will call it as internal photoelectric effect. Internal photoelectric effect. So this is the difference between the external photoelectric effect and internal photoelectric effect. In case of external photoelectric effect, emitted electrons will come out from the surface of the material. Come out from the surface of the material. In case of internal photoelectric effect, so that free electron will be generated. Free electron will be generated, but that free electrons, free charge carriers will move inside the material only. Inside the material only. Okay, this is the internal photoelectric effect. So what is the example here means PIN photodiode, PN junction diode, and avalanche photodiode. So in these three cases, what happened here? Internal photoelectric effect will occur. Internal photoelectric effect will be occur in PIN photodiode, PN junction diode, and avalanche photodiode. Okay. Now, characteristics of the photodetector.